that I saw as I walked around was this, and so you guys all started off just fine. You said, this looks like the geometric series, and so you started off with 1 over. There is some issues with memorization at this point. There was certainly more than just a couple of folks that when they wrote this out, let me get there, they wrote out just a small error here. They put 1 over 1 plus x equals all that stuff. That's what should be 1 over 1 minus x. So just be careful with memorization. The good news is you're still in process, right? You don't have to know this perfectly right now. The goal is in that 4 or 5 days you would know it perfectly, right? 4 days, 5, whatever it is. Okay. So here is where some more interesting thing happened. And I would not write this down. But there were a lot of folks that thought to themselves, you know what? I know how to make 1 minus x look like 3 plus x. And they substituted. And they said 1 over 1 minus, and I think they did like negative 2 minus x, right? Yeah. I think that would work out if you distributed the minus sign and, all that stuff, right? And then, so they continued to substitute, and they got this, and, so on and so forth, like this. And, I came by and I made the comment, look, you really haven't written an inaccuracy here, but you haven't followed the instructions. Like, what instruction has been violated at this point?
Centered at c equals 0.
And right now it's centered where? At negative 2, right? You could just set those negative 2 minus x is equal to 0, and you could see that x equals negative 2 is your centering point. And that's an issue simply because you were asked to keep this centered at 0 as opposed to centered at somewhere else. And so if you had something like that, I totally get why you did that, because algebraically it all works out, but it violates the whole it's got to be centered at 0 thing. That make sense? Okay. So I'm going to erase this, and we're going to rethink. This is going to be kind of a two-stepper. The two steps are going to be interesting. I don't know. Does anybody have a suggestion? I can just show this to you?
Add 2 to both sides.
So if I add 2 to both sides, it would be 2 plus and plus 2. I don't think that's going to turn that into a 3.
That worked, Brandon.
Good job.
It was worth a shot.
I'm going to focus on kind of manipulating the left side and then just...
Are you going to multiply?
Eventually there will be a multiplication. That's not going to be my first move.
Oh, okay. Never mind then.
Okay, this first move... Say again? Oh, okay. Now you're getting really close. So here's... You are. So check this out. 1 over 1 minus negative x over 3. This is going to seem a little counterintuitive here, but what Ashley suggested is, for a first move, is the right move. Okay? So I'm going to say this equals... 1 over 1 plus x over 3. And then that would be, approximated by the power series. It would be 1 minus x over 3 plus x squared over 9 minus x cubed over 27 plus ... Now it's alternating. So it would be this, and it would be x to the n over 3 to the n. So Ashley, I'm just kind of curious, why you decided to do that.
Okay, I'm trying to think where I started. Just because it's over 3 plus x, and there's no 3 in front of x, I was just trying to figure out how to manipulate it in a way of you could get the 1 to be a 3, and you'd have to multiply everything, multiply the denominator by 3, but then it would have to be x over 3.
To balance it out later on. Sure. Okay, I like it. I like it a lot. So I think you were really close on your second step, and your idea of, hey, let's balance out the 3, I think that makes sense. I think we can do this. You said multiply it by 3, and I think you were probably thinking right.
Yeah, I meant by x over 3.
Oh, by x over 3.
Yeah.
Now we've got it. I was thinking maybe you would multiply by 1/3, because that would get us there partially,
The denominator by 3.
and the top by That's it. Okay, so if we do that, we would multiply the top by x and the bottom by 3. So we're multiplying by x thirds. And you got to admit, x times 1 is x. 3 times 1 is 3. 3 times x over 3 is exactly what we wanted. Pretty tricky. Ashley, nice work. Okay, so let me get rid of this and put it as an equal sign. And then the power series, basically we just need to multiply the whole right side by x over 3 as well. So it'd be x over 3 minus x squared over 9 plus x cubed over 27 minus x to the 4th over 81 plus ... Still alternating. Yep. And then what do you think that other part of the nth term would be if I started it off with negative 1 to the n?
X over 3 to the n plus 1.
There you go. Yep. I'll just be consistent with how I wrote it earlier, but you're right. Come on. X to the n plus 1 over 3 to the n plus 1 would be my nth term. Okay. So I would say our, our radius of convergence is still going to be, our radius of convergence is still going to be 1. I don't know about endpoint behavior. We'd have to test that out to see. I would say we'd probably get convergence at the right endpoint, but not the left endpoint. No, I think we might get convergence at both. Yeah, I think we get convergence at both. You can double check that if you want, but I think it'd be double closed. Yes, ma'am.
So on a test, if you got a question like this, would and it include the integral convergence? Would we have to do the ratio test to
Well, so I would say if you're ever feeling insecure and you're like, oh, I think I know what the answer might be, but I'm just feeling really unsure about this. Yeah, just do the ratio test on the nth term real quick, hopefully real quick, and then test your endpoints. But what I'm thinking is I can see here that I substituted in x over 3, essentially, which would change the radius. But then I multiplied by 3, which would exactly counteract what I just did to change the radius. But I still would need my endpoint. So what I'm doing in my head is I'm saying, I know that the original interval of convergence is negative 1 to 1, right? And so I would be willing to bet that we have the exact same radius of convergence. I would just be unsure about my endpoint convergence. Would it be closed or open on those? And so what I'm doing is I'm mentally plugging in the negative 1 for x and just thinking, okay, what would happen? And then I'm plugging in the 1, thinking what would happen there. And I think in both cases, I would get an alternating geometric series whose common ratio is less than 1, or between 0 and 1, I should say. So I think we get convergence on both.
Okay.
Yeah. Okay, other questions? Okay, that's a pretty tough warm-up question. I would have loved to have done that at the end of a class after you'd gotten a little more warmed up, but Ashley, you kind of got us headed in the right direction for sure, so thank you. Okay, fantastic. So please then take a look at number 9. We're going to start to continue to use these power series to help us with this kind of a question. Number 9 is where we're at. See if this all ends up making sense for you. I think that there would be multiple ways you could do this. Did anybody look at this and say, why don't I just use L'Hopital's rule?
No.
Because you could have. I think L'Hopital's rule would eventually work fine. But if you're real honest about this, I think L'Hopital's rule would probably take you 3 times. Can you imagine that? You know, like with the challenging notational stuff with the conditions of L'Hopital's rule, doing that 3 times is going to take you a long time. Here would be an alternative. Check this out. You could say limit as x approaches 0 of sine of x minus x over x cubed could be rewritten as this. 1 minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. And I'll put plus dot, 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 because I know that that continues on forever potentially, right? Especially if I'm saying that sine of x is equivalent to that, right? It really needs to continue on forever. Oh, shoot. Sorry, the first term is x. You're going to find out in a second why I wrote that. I'm getting ahead of myself. Okay, anyways, check this out, please. Minus x from up above over x cubed. So the question is, why would this be so much better than L'Hopital's rule? Check this out. The x and the minus x add out, don't they?
Whoa.
So then, if I think about how this x cubed is going to interact with all of these terms and the subsequent terms, wouldn't x cubed get divided out of all of them if I wanted to like simplify, like do the division basically? So check this out. This ends up then being negative 1 over 3 factorial plus x squared over 5 factorial minus x to the 4th over 7 factorial plus, we know it's going to continue on in a similar fashion. What's the big takeaway here? What's going to happen with every single term save one? They're all going to 0 except for the first term, right? And so this ends up being equals negative 1/6. So check this out. What I'm about to show you, can I give you just a full disclosure here? What I'm about to show you is horrifically terrible L'Hopital's condition notation. But check this out. Can you see the 0 and 0 mentally? So you'd go limit as x approaches 0, and it would be cosine x minus 1 over 3x squared. You try to evaluate the limit again. Do you see how you get 1 minus 1 over 0 again? So again, atrocious L'Hopital notation. Yes, I'm just doing it in my head. But yeah, L'Hopital's again. So it'd be limit as x approaches 0. Now it would be negative sine x over 6x. You try the limit again. Do you see how you get a 0 on the top and a 0 on the bottom again? So it'd be another L'Hopital's rule. Limit as x approaches 0. It'd be negative cosine of x over 6. And finally, you know you're done because cosine of 0 is 1, negative 1 over 6, negative 1/6. I did that really, really fast, and I didn't even show any conditions for L'Hopital's rule at all. So can you see how the series might actually be a faster way to do something like this? So this is yet another use for a series. If you got some ugly limit, maybe L'Hopital's would or wouldn't work. I don't know. Maybe a series would be the way to handle it. Does that make sense? Okay. So the next two I love because the next two to me feel like, I don't know, like you're a detective or a CIA agent trying to figure something out. Like something's been done to something and you're trying to figure out what that something was and what the something was that was done to it, right? So take a look here, please, at the next, I think the next two is what they are, if I remember right. Yes. So we'll do these maybe as kind of a set. Do 10 and or 11. Notice what number 10 and 11 say. They say use a series that you're supposed to know to determine the function that is represented by, and then it gives you a series, a power series. Number 11, same thing. Use a known series, something you're supposed to have memorized to determine what function is represented by that power series. So, in essence, aren't we going backwards?
Yes.
The crime's been committed. We weren't there to see it. We're trying to figure out what it was and who it was done to, if that makes sense.
You got it.
Just trying to reverse this. So, see what you can do with numbers 10 and 11. Ready to go. On your own again after this might give you a hint. Like I mentioned a second ago, if you are ever tasked with this, like, hey, here's a power series, where did it come from, essentially, like what function made it, I would recommend that you analyze the factorial denominators before you analyze the exponents. Wouldn't you agree with me that the exponents push you right towards cosine?
Mm-hmm.
Looks a lot like the cosine. But then the denominators, you're like, whoa, the denominators appear to be going like 1, 2, 3, 4, 5 factorial, right? And so I don't know how to deal with that exactly. So my thought is I'm going to start off with the factorials and see if I can then manipulate the exponents to be able to, instead of the other way around. So what function that we know about goes with those factorials?
E to the x.
There's only one of them, right? It's e to the x. So maybe you'd start off by saying, well, I know that e to the x can be represented by 1 plus x squared over 2 factorial plus x cubed over 3 factorial, etc. So then you start to think to yourself, well, hey, look, thank you. The factorials match up perfectly, right? Factorials are right on the money. But there's other stuff that's off, right? The exponents go 0, 1, 2, 3 instead of 0, 2, 4, 6. And it's alternating. So what could I do to deal with maybe the exponents? What would be a good move?
Negative.
Say again?
Negative x.
Negative x what? That would actually take care of all of it in one shot, wouldn't it? So check it out. If I wrote e squared, this would be 1 plus negative x squared plus negative x squared over 2 factorial plus negative x squared cubed over 3 factorial plus ... If I clean it up a little bit, I can see pretty quickly that this actually works out exactly like I was wanting, because I was wanting to figure it out. This matches exactly with the power series that was given up above. And so I would say that that power series is equivalent to e to the negative x squared. We started off getting the factorial denominators, bless you, straight, and then we substituted to make sure the denominators were what they're, or the numerators were what they're supposed to be. Yeah.
So it's negative x because it's alternating?
So yeah, so the fact that the exponents on the original series, the exponents here go 0, 1, 2, 3, 4, 5. So they go even, odd, even, odd. If I plug a negative in there, a negative to an even is a positive, a negative to an odd is a negative, which creates that alternating pattern.
Yeah.
So you might have to do a little bit of like some algebraic manipulation and then some simplifying to get there. I think you would eventually see that, yeah, it does work out. So maybe that would be helpful for you with 11. Continue your investigative work with 11. Use a known series to determine the function that is represented by that power series. So this might take you a little shorter time now that you... Yes, ma'am.
Is this right?
Yes, it's totally right.
Do you have to show work, or can you just,
I
what are the requirements?
I would be like, it's a really simple question. I didn't really even ask you to justify yourself. Like,
Okay.
simple doesn't mean easy, but it's a simple presentation of like, hey, if you can just tell me what this thing is, I think it's good. And so the fact that you figured it out, like, I think all this work over here is lovely. Awesome. Yep. Hey, so guys, are you guys okay with this? The idea that your factorial denominators are all odd? What is the only power series that we're supposed to know about that has that pattern? Sine of x. And so if you start off with that, you can see right away that your denominator factorials are right on the money. But then, of course, the other thing you'd notice is that all of the x's are reduced by 1 degree, right? So how do you reduce stuff by 1 degree? You divide by x. So sine of x divided by x, like the whole thing divided by x, I would just come over here and divide every single term by x. That would give me 1 minus x squared over 3 factorial plus x to the 4th over 5 factorial. You can see it pretty quickly developing. This would be it, right? So sine of x over x is equivalent to that power series that was presented. And again, you're just reverse engineering this, basically. Yeah?
Wouldn't that leave off the first term, though?
Wouldn't that leave off the first term, though?
Do you start with,
I notice I never wrote an nth term, right?
okay.
So this is actually going to lead us somewhere interesting because you're thinking, hey, sine of 0 over 0, can't do it. So if I was going to define this with like an nth term, I'd have to do it piecewise. And you'll see one like this. Guys, if you could stop, that'd be awesome. If I were to write an nth term, a general term for this, like I said, I would have to accommodate the fact that, hey, if x is 0, I have an issue, so I'd have to piecewise that out. Does that make sense? But I didn't write an nth term for it. I just wrote, hey, here's a power series for it. Because the truth is, and you can tell this pretty easily by L'Hopital's rule, the limit as x approaches infinity of sine of x over x actually equals 1. And if I could just piecewise and fill the little hole that's right there, then I got a perfectly continuous graph and it would work out awesome. That's why I'd have to piecewise it. So yeah, if you did sine of 1 over x, so I'm going to just piggyback off this, of course. So sine of 1 over x to me says we're replacing or substituting x with 1 over x, right? So if I did that, then for this first one, I would replace that x with 1 over x, and I'd pretty quickly see that I'm off, because that should be a 1. Does that make sense? And if I kept going, I'd see, 1 over x quantity cubed over, and I'd think to myself, "Ugh, it felt good at the time, but I think it's off." Anybody else with a question? Okay, so tomorrow will be our final leg of the journey. We'll break out some integration. Yeah, we've already done that a little bit. We'll break out some integration, and we'll get this thing all the way wrapped up. In case you haven't looked ahead, you know that next Monday is our 9-7 to 9-10 quiz. And can you tell we're not going really fast? I'm on purpose doing, let's just do 4 a day. It's like, that's 1 every 12 minutes. We're taking our time. Hopefully that's working for you. Have a great rest of your day. See you tomorrow.
I feel like